Hello and welcome to this video. In this video I would like to demonstrate how to calculate the return of a portfolio of stock. For this video I planned the following. First of all, I would like to demonstrate that portfolio return is not about adding up prices. Then I would like to show that portfolio return is about weighing single stock returns and how to weigh them. And last but not least, I would like to transfer all that into matrix calculus that is needed later on. Here we see a simple portfolio that is made out of 3 stocks. And it is not only 3 stocks, but exactly 3 shares. So, what do we have here? We have 1 share of Adidas. We have 1 share of Deutsche Bank. And we have 1 share of Vonovia. So, we can simply assume that we have a depot or a portfolio that is made of 3 shares. And of course, since the price of Adidas at time 0, so this is the price of Adidas at t is 1, is 268, the price of Deutsche Bank is 676, and the price of Vonovia is 41.02, our portfolio has a value of 316.72. Of course, if we see this portfolio on 4 different days, day 0, day 1, day 2, and day 3, these share prices, these stock prices are moving. So here in this column, we have the log returns of Adidas. Here we have the log returns of Deutsche Bank. And here we have the log returns of Vonovia. And last but not least, we have the log returns of the portfolio. All of day T, of course, I have to add that index here. So, since I now want to show that portfolio return is not about adding up prices, we just have to add up those returns. So, minus 0.15 plus, so it's percent, I use the percent sign then, plus 1.01% plus 1.07% added up will end in 1.93%. But if we now take a look what really happened to our portfolio, so I just took the last day, right? So these 3. And if we now look what really happened to our portfolio, seemingly something goes completely wrong. The portfolio has only gained 0.04%, and that is extremely different towards what we have calculated here. Why does that happen? That happens because Adidas is so extremely expensive. It is 272.76 euro, and that's a huge part of the portfolio value of 323.09. I don't know the exact number, but I would guess it's about 75 or 80% of the portfolio. So Adidas dominates the whole portfolio, and Adidas has lost 0.15% this day. Accordingly, we can't gain as much as we have calculated here. So this is completely wrong or erroneous, right? Let us have a look how we can improve this idea. We now come to the conclusion that Adidas is dominating this portfolio, so why not weighing the portfolio the stock returns? So what are our weighs? Our weighs are the starting prices. So this is the starting price of Adidas that is used to calculate this return. This is the starting value of Deutsche Bank that is used to calculate this return. This is the starting price of Vonovia that is used to calculate this return. And this is the value of our portfolio that is used to calculate this return. If we now weigh all those returns by the value of the stock. So I start with Adidas, 273.16, that's this day here, divided by the portfolio value, 322.96, and this is the weight for minus 0.15%. And we do the same for Deutsche Bank. First we calculate the portfolio weight, 6.93 euro out of 322.96 euro are invested in Deutsche Bank times 1.01%. Plus 42.87 divided by, again, 322.96 times 1.07. That will end up in 0.04%. So this is the way we calculate the portfolio return. So, why is this the correct way? Well, I would say it's straightforward. Nevertheless, let us have a look only at this part and let us put it into formula. So the weight then is P of share 1 in time minus 1 for this day, of course. It's the value of yesterday. Then we have P of the portfolio here. No, I don't want to use that. Maybe I want to use that, I don't know. So of the portfolio, again in T minus, I'm too close to this, minus 1. I'm sorry for that. So times, again a fraction line, because we're now going to calculate. So this was 273 divided by 322. So this is the portfolio weight. And now we're going to calculate the portfolio return. But I use the simple return here. I don't use the log return, just to make things easier. So the price of share 1 in time t minus the price of share 1 in time t minus 1 divided by the price of share 1 in t minus 1. So this is the simple return, just as I showed it in previous videos. Of course, they are both multiplied. Here comes the other shares, of course. And that will end up in a portfolio return. If we now shorten out the price in t minus 1, we see what happens. We see that we have here the price difference of share 1. So the increase or decrease of the stock price in euro divided by the portfolio value in t minus 1. There's a 1 missing, I guess. Okay. So we see the contribution of this stock, Adidas in this case, to the portfolio value. And that's why it works out. That's the reason why we simply can weigh the returns to get the return of the portfolio. Now, some matrix calculus. Before we start with matrix calculus, of course, we need to write down the portfolio return without any matrix calculus. Of course, the return of a portfolio is given by the weight of share 1 times the return of share 1. You see that I don't use any time indices here because it is true for any choice of time, so we don't need it here. Times, no, not times, but plus some further ones, plus the last share, the weight of the last share, which is share n, times the return of the last one. Well, and of course we can write it differently with a sum sign, and it is I starts with 1 to share n, the weight is I, and the return is I. Alright, well, most of the things we write with a sum sign, we can also write with vectors. So let's make a vector of weights first. So here's the vector of our weights. And let's make a vector of returns. Oh. And let's denote those vectors W with an arrow and R with an arrow. Okay. Now we can of course multiply those vectors and get RP, so the return of the portfolio, by W, the vector W, the weight vector, transposed times the return vector. Why that? If we use vector or matrix calculus, the transposed vector of W would be W1, W2, some more until Wn, and the return vector is still R1, R2, some more, and Rn. And now we can use the cross product here. Thus we have to multiply W1 with R1, W1 times R1 plus W2 times R2 plus plus Wn times Rn. And that's exactly the definition that we wrote down here. Alright, I hope this video helped you. Thank you for listening and see you in the next video.